We will have a look at modern data warehouse architecture, an example of how this can be built. We're going also to show you an example of a use case for demand forecasting. This is a bit retail-based, and we'll just show you some of the amazing possibilities that you have with these technologies, and just show you a little bit the steps that you can take to unlock the full potential of your data. Yes, so welcome again from our side. Maybe we can quickly introduce ourselves. So with me in today's webinar is my colleague Stefan Jakob. He's head of sales at BS Group Data Analytics. He will be mainly being in the chat. So if you guys have questions, please feel free to reach out via the chat, and Stefan will then collect those questions. And we have planned that the webinar is going to take between 30 to 40 minutes, and the remaining of the time is going to be a Q&A session where we can then try to answer all of your questions. Then maybe 2 words about myself. My name is Roger Unholz. I'm a partner and a senior consultant here at BS Group Data Analytics. Maybe from my background, I have been now working in the data analytics industry for a little bit more than 12 years, mainly focusing on Microsoft technologies, be it like a traditional data warehouses, and obviously, of course, the last couple of years, more and more cloud technologies as well. All right, I just want to give a few slides or a few words about who we are as a company. We have been founded in 2016 and are now 14 consultants with over 50 projects that we have been doing during this time period. We are focusing completely on Microsoft technologies, only on Microsoft technologies, and have been certified as a Microsoft Gold Partner for the last 5 years. Our goal is really to enable you to get the most out of your data and to really guide you through the digital transformation of today's challenges with data. Maybe a very quick overview of some of our customers that we are working on. We are based in Zurich in Switzerland and also mainly focusing on the Swiss market. But within this, we don't have a specific focus on an industry. So we have really customers from different industries. Some examples maybe from retail. We have been working with Manor, with Denner, for example, but also some other industries like, for example, Autoneum, which is a car manufacturer, like a supplier for car manufacturing, yeah, and so on. So this is just like one part of our customers that we are working with. What are we focusing on? As I mentioned before, we really try to do the whole stack of data analytics, starting maybe at the bottom, where we do a lot of projects in terms of data governance, metadata management. In this area, we work together with a partner, DataSpot. This is a company from Austria. And then in the middle, our main, I would say, services is really everything related to data analytics, data science, cloud strategy, and in here, really focusing on the Microsoft technology stack. On the very top, we also have a collaboration with AFC Software. This is a corporate performance management solution, which is mainly here to do budgeting, forecast, consolidation, like financial consolidation of your figures. But this is also a Microsoft technology-based solution. This is together with the company SolidWorks in Denmark. They have been now entering the German-speaking market since last year, and we are helping them as a partner to do a little bit the market entry in the German-speaking countries. Yeah, that's enough about us. That's what we do. Let's dive into today's topic about data analytics and about the modernization of your data warehouse. I want to quickly talk a little bit why we need to modernize your data warehouses or the current data warehouse situation. And this specifically has to do with what we want to achieve with our data. So in the end goal is to have the most possible business value with our data. Traditional data warehouse systems usually have been on the more left side of this chart. So for example, if we have a look, we see that we have more solutions which are based more on past activities. So basically we tried to do more descriptive analytics and diagnostic analytics. So we wanted to understand what happened and why did it happen. So this is really what traditional data warehouse systems were good at doing. So we could really collect the data, integrate it, combine it together, and then do analysis, checking what has been happening and why did it happen. So maybe finding the main reasons. This is all more like looking into the back mirror. So it's really more past focus. And then now the challenge is that we want to start to be a little bit more predictive. So saying that we want to achieve and see what will happen and how can I make it happen. So basically really that I start to really predict the possible outcomes and maybe even how can I influence that I can achieve the outcome I want to have. So, and here it's really not only like collecting data, but maybe even generating new data. And with the traditional technologies that we had in the past, this has been really challenging to accomplish. And I would say just in the last couple of years, especially with the adoption of cloud technologies and the power of the cloud, we have been able to really make a lot of steps forward in terms of what can we do to predict the future, to bring new technologies, for example, with machine learning, with AI. So this helps us to really then get even more business value out of our data. But this whole thing brings again a complete new set of new challenges. So for that, we needed a completely new architecture, or like the tools that we were using to do that were not enough. So we needed to really have new tools, new technologies, which help us to achieve this. And for that, we have here a modern data warehouse architecture. So this is very, very high level, a possible architecture how your modern data warehouse can look like. We are Microsoft partners, so we are really focusing on the Microsoft stack. And what you can see, very traditional, very classical on the left-hand side, if we maybe go a little bit over here, we have a bunch of different data that we need to be able to do our analysis. So we have the typical on-premise database systems, so the more structured data. We have maybe some cloud data which is available, which might still be structured data. And we have something that maybe came up the last couple of years, which is, for example, streaming data, which can be, for example, sensor information, IoT, Internet of Things. And all this kind of data we want to be able to collect, to process. And for that, we are using mainly a technology called Azure Synapse Analytics. This is a platform from Microsoft in the Azure cloud, which allows us to really have one technology stack which helps us to achieve all the other steps. So basically what we really do is we extract the data using this Azure Synapse Analytics. And in here we have pipelines, for example. We collect all the data into a data lake. This data can be really different kind of formats or file formats. We collect everything in a bronze layer, we call it. So it's really just the raw data as it is. And from there, we start doing transformations and cleansing of the data into a so-called silver layer, where we already have some data cleaning in there. And now here is where basically between the silver and the gold layer, where we start to do more the aggregation, do more like a business modeling, so that the data is consumable, especially then for the end users, for the business analysts, for managers who need to then be able to see the data in a meaningful way. And what we also start to do in these two layers is we start to maybe enrich the data. And for that, we have things, for example, like here at the bottom, like Azure Machine Learning Services or Azure Databricks, which are two services in the Azure cloud, which allow us to do data transformation, data enriching, and also to use machine learning algorithms to create new data, to build machine learning models, which allow us to, for example, score or predict data. On the very right side, then, we expose this information or this data, for example, using Power BI. I'm pretty sure a lot of you people are maybe familiar with Power BI, which is then basically one of our possible front-end tools, how we can then get the insights, get the reports on top of the data that we just prepared. We go maybe a little bit more into detail about how this can look like, or what exactly is this Azure Synapse Analytics. It's basically more or less similar to what I just showed. It just goes a little bit more into detail what kind of components are there, especially to like explain a little bit how the different kind of data can be processed and can be integrated. So for example, when we look at the streaming information or streaming data with IoT devices and so on, we have, for example, services like Azure Event Hubs, Azure IoT Hubs, which help us to really process this data in basically real time. And we have all the other data, for example, the unstructured, semi-structured data, the databases, which we then all ingest and collect the data with Azure Synapse Analytics. And in here, we really have, for example, the pipelines, as we saw before, which help us to orchestrate the data. So we can say, okay, we want to have schedule extractions once a day, multiple times a day, or we want to have event-triggered data extraction and ingestion. And all of this data, be it from the structured, the semi-structured data, or be it from the more real-time data, we collect all together here in the middle into our data lake. So our data lake is basically really our centerpiece, where we collect all the information, all the data that we have. And then from there, we use other components of Azure Synapse Analytics, like, for example, Spark Pools, which is then helpful for doing all the transformations, all the cleansing of the data. And then, of course, the database, I will call it. Here we have two options. We have, for example, a serverless pool. Basically, this is a database on top of just the files which we have in the data lake. Or we can have as well a dedicated SQL pool, which is the enterprise data warehouse capability, where you can really process and query hundreds of terabytes of data with a complete scalability of the system. As I said, again, in here, we have the whole machine learning part, which is at the right top here, where we can include machine learning algorithms to do some scoring, to do predictions, and also things like cognitive services for translations and so on. There are really a lot of different capabilities which are provided within this Microsoft ecosystem. And once we did all the preparation, all the cleansing, we can use, for example, then Power BI to do the analytics, the visualization for then the reports, the dashboards, and so on. So this is really the complete ecosystem, which is integrated in one single place with this Azure Synapse Analytics. Well, I think enough of theory. I would like to maybe discuss a little bit about a possible use case, a use case that we have been doing with one of our customers, for example, and this is supply chain. So the supply chain, we believe, should be consumer driven. And what do we mean with consumer driven? This means that we have our consumers, we have people who are providing data, and we should be able to forecast how is the demand going to look like. So demand forecast is, to explain it a little bit, is basically the process where we use sales information like historical sales data, information about promotions, information about maybe our customers, our shoppers, and we collect all of this together and try to understand and to predict the future demand of the customers. And with this information, then we use all of this output and this information then to optimize our complete supply chain. Basically, how does a typical supply chain look like in the retail sector? So basically, we have on the very right side, we have the shoppers. This can be different channels, I would say. So we have on one side, for example, just the people that traditionally go to the store and they buy the products in the store. But we have also a bit like more modern things like e-commerce, for example, so that we order online or with an app. We also have things like basically pick up at the store. So I order online, but I pick it up in the store. And we have also business models, which is, for example, subscription based. So basically, I'm just providing like basically a platform, and the whole logistics don't go through my distribution centers anymore. They just go directly from my supplier, from my manufacturers, directly to the end customers. And as you see, like especially here on the right side, those are the ones that basically generate the data. And here is basically where, if I continue here, where I want to do the demand forecast. So I want to forecast these people. So how can I predict how they will buy in the future? And if I have this, like if I once get this information, this will influence the whole chain at the back again. So basically what happens then, if I get the information of the prediction, I have possibilities to adapt, for example, my intra-store shipments. So basically, if one store is low on stock, maybe we can do some shifting of stock between stores. For example, I can maybe also optimize the inventory levels of my distribution centers. So I can optimize also the store shipment. Basically, maybe the frequency when I have to ship from the inventory, like from the distribution center to my store, like maybe the quantity and as well the frequency. I can, for example, optimize the needed inventory for home delivery, like for the complete home delivery logistics, especially in terms of e-commerce. I can also give this information to my manufacturer to optimize the direct shipments from the manufacturers to the end customers. So this is all information that I can then use, and I can optimize my whole supply chain. So you see there are really a lot of different parts which I can then optimize and which benefit from the prediction of my demand. But this is challenging. So basically to use machine learning and to use data to optimize the supply chain is not easy. I have different challenges. For example, I usually have a limited access, or I have just limited real-time and external data. We saw this whole omni-channel strategy where I have different channels where I get information. And then I can even include more additional external data, for example, local data like the weather, which might influence. I can also maybe use IoT data, which is maybe coming from the manufacturers. I can also maybe use casual data, as an example, the pricing of my competitors. So maybe I want to even try to react to the pricing situation of my competitors. So there is a lot of different data that I can include additionally to my already existing sales information and historical sales information. What this means is that the amount of data that I have to use is very big. So I have really large volumes of data, and this data changes very frequently. So this is, again, an additional challenge which with traditional data warehouse systems has not been so easy to tackle. Then the next thing is the forecasting. Usually the forecasting has not been very accurate and has not been very precise, especially if we say we want to be able to forecast on very low detail levels, say per day, per store, even down per product. So this is really something that is not so easy. And of course, all of this data that I collect, I need to be able to convert this into actionable insights. So I have to provide like all this bunch of information to my managers, for example, to my store managers and to my distribution center managers. And you know, those guys are usually always busy. They have to run the operations. They don't have time to be exploring the data. They really just want to have a solution which helps them to say, okay, now I have to place an order. Now this has to happen as automatically as possible. Yeah. So how was this done in the past, or how was forecasting done usually? Usually you just had different areas. So you had, for example, from the product side, you had your promo groups. You have, for example, your markets, basically your stores, and you had the time domain, be it, for example, weeks, months, and so on. So basically in the past, typically the forecast has just been done basically on one of those domains. So, for example, you did a forecast on a promo group or on weekly level for like, that's it. And so because the challenge is that if I start to do the combinations, I start to get a lot of different possibilities. So basically it's each product, like each combination of product and store, for example. So the amount of data already explodes. And if I then continue and do this, and I have to like basically create a machine learning model for each of those different combinations, if I have to tune this for each of those combinations, this is very, very slow and very time consuming. So if I really want to have this level of detail, usually this took a lot of time, and it was basically something that once it was done, it was not relevant anymore because it was just too late. On top of that, as we saw, we also have some casual information and local information which can influence the accuracy of the forecast. So we saw we have the combination of stores and products, but then we also want to include local data like the weather. This can influence the behavior of the customers heavily. We also have information like demographics. We also have information like special events. This is something that we saw that is very, very important. So for example, if there is like a concert or sport events, this can have high influences on the demand of certain products. And we wanted to take this into consideration. And the only way we could do that is by leveraging the scalability of the cloud. So here with the traditional systems, it was just not possible to bring all of this information together and process it in a good way to get good results. So for that, what we did is we really leveraged all the potential of the cloud, that we can really scale up. We can parallelize the creation of those models, and like that, we were able to then create a forecast for that. Yeah, what did we get, or what is the result of this whole exercise? Just to mention two possible applications that came out of it. One was a forecast report. So basically that we have really for each single store, they can have a report where they can look how the demand is going to be for them. And the other possible application was out of stock alerts. So basically that we say, oh, based on your current stock and the prediction, there might be an issue, and we recommend basically to do, for example, an order to your distribution center, or maybe an order to your supplier, so that you can avoid an out of stock situation for a certain time. So this is just two examples on how we use this then later on. And there are many more, and this can be extended. But I just would like really to show you an example here, specifically about this demand forecast report. So if we maybe quickly change now to Power BI. So this report is now here done with Power BI, and it basically contains exactly that what I was showing you. Let me move here to the right side. So we have, for example, a filter where we have the stores. So each store manager basically can go and look into his own store. We have here as a filter possibility basically all of the products which are sold in this store. I'll just now use a few of them. And of course, I have a time domain where I can say what do I want to see, or like which is the time frame I want to see. And what we have basically is the quantity. The dark blue one is basically the historic quantity, like the sold quantity. And we have a blue one, which is the predicted quantity that we see for this particular product. And like that, you can really then go until the last data that you have. And after that, you see that we have a quantity which is predicted. This whole model is really taking into consideration topics like seasonality. So some products have seasonality, some products don't have. It also takes into consideration, as I mentioned, special events, topics like holidays, vacations. This is something that is taken into consideration. And with that, it really tries to get an as close prediction as possible. If we see it here, for example, if we look at on weekday levels, so we see that the prediction is really quite close to what actually was sold. So this is really the benefit that they have. People can look into their own products that they are maybe responsible for. So you see this is all there, and it's quite responsive, it's fast, and they get this refresh basically every single day. So every day at night, the next prediction is happening, and we usually did a prediction for the next 60 days. So this is the usual time frame that we used for the predictions. All right, let me change back to my slides. Yeah, basically this was the report I wanted to show with you. Key takeaways, if you say, okay, you need a modern data warehouse, is really, it allows you to implement new use cases which have not been possible in the past. So it's possible to not only do the hindsight analysis, so not only to see what happened, why it happened, but also to unlock the possibility to look into the future, to predict what is going to happen, and maybe to influence what will happen. For that, we leverage the power of the cloud. In our case, we mainly focus on Azure Synapse Analytics because this is really the one tool set from Microsoft which allows us to really process most of the data, to really build these solutions. Of course, with additional services from Microsoft, like the machine learning services and so on. And what we achieved was that we could create a really fine, detail-grained demand forecast, which was able to be like refreshed and done on a daily level. Like every day, they got a refreshed, improved prediction for the next 60 days. What we always hear, or we hear very frequently then from customers or from companies is, well, I think this modern data warehouse is maybe not for me. Maybe we are too small for that. But in our experience, what we usually say is that's not the case, because with the cloud, with the scalability, you can also start small. We always used to say, think big, have a big idea, but start small. So you can really go then in small increments. We always encourage and recommend to do things like experiments. So even this example that we showed you, we started with an experiment of this use case. We evaluate and test a specific use case if it works with the data that we have. And once we are happy with the result of this experiment, of this use case, only then it gets more, it gets into a working concept, and it gets deployed to a production state, and it gets scaled up, maybe rolled out then not to one single store, but it gets rolled out then to the entire stores that you have. So this is really the benefit of the cloud, of this modern data warehouse, that you can start small, just do experiments on a very, very, I would say, limited area. And once you see that it's working, you expand it and you can scale it to your operational and your production level. If you're interested, like if this is something that you think this could be something for you, what we would like to offer is we have a modern data warehouse coaching hour. What do you get in there or during this session? We will look with you together at your existing use cases or your reports or architectures that you have. And we try really to help you, to give you recommendations about the best architecture that you can build to realize those ideas and those use cases. It's really, for us, it's no sales. We don't want to sell you a product or whatever. It's really to give you recommendations about best practices, how you can set up this kind of modern data warehouse within your organization. What do we need from you? We would need 1 to 1.5 hours of your time. This is completely free of charge, and you can bring your use cases, your ideas, or maybe your current architecture that you have. And with that together, we would do a session where we look at your current situation, what you want to achieve, and maybe give you a roadmap how you can then do the shift or the change into this modern data warehouse approach. How can you request such a session? My colleague Stefan will post something. Will post a link in the chat, but you will also see it. You will also see it here in the slides, which we will share with you guys. And on top of that, what we also give you if you sign up for this session, you will also get a best practice data visualization white paper, which helps you to learn about some best practices for data visualization using Power BI, for example. All right, this would be from my part it. If you have questions, please feel free to raise your hand, to ask your question in the chat. Yes, so we are still here. Feel free to maybe unmute you. Stefan, maybe you can help with that. And otherwise, yes, please just contact us directly or through the link which is shown here in this site. Thank you.
Thank you, Roger. Yeah, so to all the guys, I unmuted you. So if you have any question now, just raise your hand or just directly unmute yourself and talk. And I placed the link. So in case you have any questions about data warehouse modernization, connecting your source systems, about BI reporting, just feel free to book a meeting with us. We would look forward to. And of course, if you have now a question to Roger, feel free to ask directly. All right, Roger, it seems no questions so far. Thank you very much for the webinar. Thank all of you for attending. I hope it was helpful and you got some insights. And we look forward to hear from you and wish all of you a happy and a nice day. Bye-bye.
Thank you. Have a good day. Bye-bye.